Okay, so I was going to do the next part of the tool as a bit of tidy up and adding in the start of some multi-platform abilities, probably the spectrum, something like that. But as I've been asked to do some tutorials on Sam Coupe actual game programming, there's one more feature I'd like to add in first, which is tile maps. Tile maps are in some ways a bit like sprites, so this is a tile sheet. Each tile is the same size. They're usually square, don't have to be, but convention is to keep them square. And then maps are built up using these tiles. So these tiles can be used multiple times over a map. I've also created a little tile map here using them. Obviously I haven't used very many of them, I'm no artist. But you can see, so we've used the same block time and time again. They're all on a set size. So if the tiles are 32 by 32, in this case they're actually 64 by 64 on this image, all the tiles will be, so tile 0 is at x0, tile 1 is at x64, tile 2 is at x128, and so on. Unlike sprites, they can't move around individual pixels. So what we're going to do is we're going to write some functions. I've put some details in the script here, so we can grab tiles to a specific tile set. A tile set is a collection of tiles. So this grab blank tile, in this case passing in RGB, this will grab a tile and just set the tile to a single solid color. It's quite useful sometimes to know that your tile in x0 is always a blank tile if you want to change anything, or see if you can move collisions and things like that. We'll have a grab specific tile. So here we give an x and y and a width and a height. On this one, obviously, we gave a width and height and the color number. We'll also have a look at tile map. A tile map is where we grab an image like this. It cuts it up into lots of individual tiles. We pass the name of the tile map, a name of a tile set, which we may have or may not have already created, and the size of the tiles. The idea being, if we just cut this up as a tile map, it would repeat the same. It would cut up the first tile and go, oh, actually I've used this tile multiple times, therefore I only need to store one copy of the tile, and it creates a map to tell you which tile you need in each individual place. We'll see how it actually works a bit later on. So the first thing we need to do is we need to store a tile. A tile, as I said, is very close to a sprite. There are some differences, but for intents and purposes of this converter, I'm going to say they are pretty much a sprite. Not so much I'm going to use the sprite. I'm going to have its own class. It's always worth, even if it is going to be basically the same, it's worth having its own class, because there might come a time when it's not. Oops, actually editing the wrong one there. It's not the same class. Sorry, it's not exactly the same. But for now, a SAM tile is going to have a width and height. We're going to add data to it exactly the same as we did before. We'll need to get information about it. So, as I said, it's basically a sprite at this point in time. So we'll just create that. The next thing we're going to need to create is a new class that is called new class. This one is going to be called Tileset. So Tileset is what stores all of our tiles. A couple of things we'll need to store is the width of the tiles, the height of the tiles, and a dictionary of all the tiles. Or the list of all the tiles. I've got one new. When we create a tile set, the only thing we really need to tell it is the width and height. And we'll set the width W, the height H. While we're here, we'll just write a couple of quick accessor functions. Get width. And we'll also add a get height. Get num tiles. Because we're bound to want to know that. And obviously, if you're storing a list of something, at some point you're probably going to want to get it. So get tile idx. Return tiles tile idx. Possibly could add some checking in. That's fine. Okay, so there's some basic functions for our tile set. So the first function we had on here was a grab blank tile. And so we need to create a new handler. I'm just thinking about creating a new one, or pretty much start with one that I've already created. It's going to be very similar to grab sprite. Unsurprisingly, yes, they're similar. So we'll grab this and we'll call this grab blank tile handler.cs. And there it is. Clear out the bits we don't need. Okay, so our is valid for this. We are going to have two options for the blank tile, as I said here. One takes a name, width, height, RGB. One takes a name, width, height, and the working palette index. So we've got 1, 2, 3, 4, 5, 6 or 4 parameters. So it's not equal to 4, that's not equal to 6, we know we've got it wrong. The first two parameters are always the same, so if first three, in fact, so if not, the first one's string, but we need to make sure that the width and the height are integers. If not, we know there's an error. Now, if there's arguments of 4, we need to just make sure that the third argument so the third argument needs to be an integer. If as well, because it's a palette index, we know that it needs to be greater than 0. And it must be less than 16. So greater than 15. Then that's a problem. Don't actually need anything else because we've checked above. So in this case, we're talking about an RGB value. So arguments 3 is less than 0, and again RGB, so 255. So RGB 4, oops, 4, 5, 4, 5, 4, 5. So this is just checking R, G, and B are integers, and they're in the range of 0 to 255. Okay, we can probably get rid of this. My wheel ball is playing up, as you can see. Blank tile set. As we said in the script, the first one is the tile set name. So same color, get the size. Let's read in the width and the height. range. So we get that way we know what the width and height of the tile is. Now this is where we're going to have to start. Oh, we can do it next now. Get the so if get number of arguments. So if we're passing in, if it's 4, we're passing in the actual Sam color. So Sam color equals sc dot get argument as integer 3. That's all we need to worry about. Again, we don't need to worry about it because we've checked and validated everything above. This is where we get the RGB. So R get argument as integer 3, and we'll get G, we'll get B, and this is 4 and this is 5. So now we've got RGB. Now what we need to do is the Sam color will equal get working palette. So that's the palette we currently got, and we want to get the closest Sam from RGB, from A RGB, and R, G, B. So that'll get the closest color that we can use. The trouble is now we need to create a tile set, or at least find a tile set. So we're going to be creating our tile set. Again, it's going to come from our export data, very similar to sprites. We know the name, and we're going to need to pass in the width and the height. Obviously, we don't have this function. This is one of the things that I was looking at tidying up. The problem with writing this as I'm going along is there's no pre-planning. So quite often what you'll find is if you haven't pre-planned something, you're working along and you suddenly realise that there's a better way of doing things to tidy up and to stop a lot of duplication. As you can see here, if we go to our export data where we're going to have to add this add tile set function, like we've got sprite and palettes, the fact that I've got it twice and I know I'm now about to copy it again to add a name tile set, to me, if I'm having to copy code like this, it's wrong. It feels wrong. It looks wrong. I'm having to duplicate large quantities of code. There's no reason to duplicate code. Just add the reset in here. We have to keep remembering to code, like we have to remember to reset it, because otherwise, if we don't, we'll get problems later on. It's just untidy having all this, and later on you see we're going to have to add a tile map. So in fact I might even add this now, because while we're in here we're going to have a tile map class that's going to need to be in here. So let's do all the work in one go. There's a better way, is what I'm trying to say. In another video shortly, I'll show a way of making this much tidier, reduces the amount of extra code. Because at the moment, I've already got palettes, sprites, tile sets, tile maps. If I decide I need to make a change, I've got to change it in 4 places already. It's error prone. It leads to problems. Don't do it. Think about it. There's usually a better way, and as I say, we will cover it. Because what we're now about to do, as you'll see, why I hate it, but for this video, we're going to live with it. We're going to copy all those functions, and we're going to go as tile set, tile sets, get tile set, tile set. There is a reason I haven't called it Sam tile set, in anticipation of another video. The tile sets themselves, the tile is specific to Sam. The tile sets and the tile maps are generic. They will work on whichever platform when we come to multiplatform. So I've not named them Sam or prefixed them as Sam. we will come on to here. One difference is we pass in the width and height for a tile set, so we need to pass in a just the width and height. Should be happy now. There we go. And as I say, it's so wrong because I'm now going to copy it all again. And we're going to go as tile map. Tile maps. Tile maps. Tile maps. Tile maps. Tile maps. Tile maps. Get tile map. We may need a width and height. I can't quite think at the moment until I come to do it. So we'll just create it and then we'll worry about that when we actually come to use it. Did I add a clear? Yes. So yeah, so you can see it feels very wrong. If we've got this huge long list, all doing the same thing, just returning different ones. We'll come back to it. It's a quick tool, so sometimes you just have to live with these things, but we can fix it later. But now we've created these, if we go back to our grab blank tile handler, before we add this, so we've now got a tile set. Now what we need to do is we now need to create a tile. So we're creating a tile. We know the width and height of this tile. All the bytes in this tile are the same colour. And that is going to be, it should already be, but let's just check. Obviously with Sam you need 2 pixels per byte. So that's our colour, and in total we're just going to have to set all of them, so just in case someone passes in an odd width, add one before we shift it. Now what we're going to do is just going to set all the bytes. So we've now created a blank tile. We've created a tile, and effectively we've set the width and the height to blank. Now, this is where it starts to get fun. Tileset.add tile. We haven't written this yet. We're about to. And we're going to add a tile. So at any point we can add a tile to a tile set. As I've already said, tile set has a list of tiles. So what we want to do is we now want to add the tiles. Let's add a function. The return value for this is going to be the tile index. The reason we're going to return the tile index is because, as we said at the start, when you're using an image like this, if we're just reading through and creating this, we read this tile here, it's plain green, create it, add it to our tile set. Read this one, create it. We don't want to add it to our tile set because it's the same as the one before. There's no need to add it. So what we want to do here is when you pass in a tile, we want to see if, first of all, it's the same. So If new tile, the most important thing, it's got to be the same. The tiles, all the tiles in a tile map have to be the same size. If they're not, you're in for a world of pain. From memory, actually, there was a tile system that did have different size tiles. There are occasions that you can do it, but you really want to know what you're doing. 99.99% of the time, tiles are all the same size. It just makes life easy. Let's print an error. Is not equal. So if the width or the height are different sizes, is the wrong dimensions. And we'll return -1 to say there's a problem. So that's because come across it. So yeah, so if the width and height are different, if we're passing in a tile that's the wrong width and height, then that's bad. We now need to compare it with all the other tiles that we've got. This is a tool, this is designed to be easy. If I was doing this, if I was doing this for me, what I would personally do is I would create something like a CRC code for the tile, which it's just an integer, which is usually works with polynomials. It creates a 32-bit number which represents the data that's in that tile. It's a good first check, because then we could just check if those numbers are the same, because if you pass in the same data, you'd get the same CRC out, so we just end up with an integer. A basic CRC could just be a case of adding all the bytes together. If you get two tiles that are the same, you add all the bytes together, they get the same number. It's a quick comparison. You can't rely on it purely, but it's a quick way of, you can reject tiles very quickly, so you don't have to do the slower methods of comparing for this. I'm just doing the slower methods of comparing. As I say, it's a tool. What we've done here is we've grabbed the data from the tile into a byte array. We've already got that function. We used it when we were exporting the assembler files for sprites, and we've copied this from the sprites. What we're doing here is running through all of our current tiles, and we want to know if the new tile is the same. This .NET has got a nice little function we can use to compare the binary arrays called sequence equal. If it gets into here, what this means is data here, which is our new tile, is equal to this tile. So the two sequence of bytes are identical, the two arrays are identical. So in that case, we don't need to add our tile, because we've got one that's the same. So don't bother adding it. If we get to here, though, we didn't find a match. So then we know that this is a new tile that we haven't seen before, so we can add it, and we now need to return the tile number. Oh, can't type now. Obviously, the first tile we add would make count 1, but its tile index is 0. So remember to subtract your 1 when you return the tile number. So all we've done here is when we add new tile, we check it's the right size. We then run through all the tiles that we've currently got, which if you've got a lot of tiles is very slow, which is why I would normally do a CRC, but I don't think it's a major problem. If we've found it before, we say, hey, it's okay. You're the same as this tile number. We don't need to add you to our tile set. If you don't, we add it to the tile set and return the new number. So now if we go to our grab blank handler, one thing we do need to do is handle the fact that it could be -1. So if it's equal to -1, that's where we're trying to add a different size tile and that sort of thing. Let's return false just to say there's a problem. The bit I always forget. Forget to add this in, so grab blank tile. It's because we've added the tile maps in. We'll come back and run it later. Before we get to the tile map, though, the other option we had here is grab an actual tile. Again, tile set name, X, Y, width, height. What we'll do is we'll start with this one again. So we want to grab, it's not blank tile this time, it's just a tile handler. If we do edit our files, make sure we edit the right one. Get caught by that several times. That's what I get for copy and pasting effectively. Tile handler, don't need any of these again. Is valid. We've only got 5. Name, X, Y, width, height. So is 1 or 2. Check X, Y are integers. And check width, height. 1, 2, 3, 4. Okay. So now we want to grab tile to tile set. So now we're actually grabbing the tile. X and Y, because this is based off sprite, this time X and Y are not going to be 0. Let's grab all of that junk. Paste over here. So we want to get 1, 2, 3, and 4, X, Y, width, height. We'll leave that bit, we'll come back for that because it's probably going to be useful. Again, we've got a tile set. Tile set equals add the tile set. If this will obviously, as with sprites, this adds it if we haven't already got one, otherwise it returns one we've already got. Pass in the name, pass in the width and height, because every time we need to pass that in so it knows what size the tiles are in the tile set. We're going to need to create a new tile, because we're grabbing a tile. Again, width and height. Because we're grabbing graphics, we will need the working palette, so we can leave that. Similar to sprite, we're going to run through the width and height, we're going to grab the pixels. The only advantage here, tiles don't have masks. So we don't need a mask. So we're just going to grab the closest colour for pixel P1 and mask in pixel 2. And we don't have options. It's literally going to be tile.addData. So you see, it's relatively close, but as with tiles, as with tiles, we need to add it to tile set. again, that will go through and check and return if it's the right one, but because we're just grabbing tiles, we don't actually care about the tile number. But we do care if it returns -1 because it means the tile's the wrong size. Okay. So this will effectively grab, it's very similar to a sprite, this one. We're just grabbing a square chunk of graphics into a tile and adding it to our tile set. That's all good. So the last thing we need to worry about is our tile map, and this is where we grab lots and lots of tiles, and we also need to store which index of tile we are. So first thing we're going to need to do is create a new class. It's called tile map, and this is where we will be storing all our details of our tile map. Now, tile map will have a width and a height. This is in tiles, not pixels. So you do need to remember the fact that you're working in tiles now. We'll store all the details of all the tiles. Let's say which tile number goes in which space. And then constructor, we're going to need to know how big our tile map is. So pass the width and the height. Because we're creating a tile map with a width and height, we know the size. So I know they put width and height. I prefer to have height. Don't know why. Doesn't actually make a difference. You can pass width and height, or you can pass height and width. Int public. Again, we'll just add some quick access functions. Get width. I know there's C# has the get set functionality. I don't know. I use it occasionally, but for things like this, I tend to like to write the functions. It's just more obvious to me for when we're doing things like this. Another quick function we can write is set tile. So pass a bool, return a bool to say whether we're done or not. This we want the x, the y, and the tile ID. If tiles is equal to null, we have a big problem. So return false. X is less than 0, or x is greater than or equal to width, or y is less than 0, or y is greater than or equal to width. Then we have a problem because we're trying to set a tile off the side of our tile map. If all that's done, then tiles, nope, because I'm doing it the wrong way around. I'm going to use y and x equals tile ID, and we can return true. Don't know why I prefer y and x, because if you're doing its coordinates, I'd be happy. It's just because it's a map, and to me, these are the rows and these are the columns. Okay, so that sets a tile. So the only thing left to do, now we've got a tile map, which will hopefully make our compile happy. Tile map. These are just the errors where I was adding the function. This is why it's bad, because as you can see, even just adding these two, I've done copy-paste errors. Copy-paste is the root of most errors. We will need to pass in a width and a height of the tile map. And this is easy to see how many copy-paste errors you can create. Okay. But what we now need to do is we need to tile. Let's use the grab tile function. It's going to be slightly different, but that will do. Create a copy, called grab tile map. Grab tile map handler. Okay, now the grab tile map, we want to pass the name of the tile map, the name of the tile set that we want to create or use, and the width and the height of the tiles. So we just need to know if this is equal to 4 and 2 and 3 need to be integers. Grabbing tile map, and let's also say from tile set. So we're grabbing this tile map name and we're grabbing it using this tile set name. Now, we've just literally got the width and height, and they will be in 2 and 3. Now we want to find the tile set, except it's going to be number 1. The width and height is obviously the tiles. We're not going to. We will need the. We need the working palette. I think we will need the working palette from memory. Now, we could actually, with this script, we could actually pass in a width and an x and y and a width and height that we want to grab the tile map from. I'm just going to work from the entire working image. So get the tile map dimensions. So image width is going to equal get working image width. Get the image height. From that we can work out the map width and height. So take the image width, divide it by a width, that gives us the map width. That's how many squares, how many tiles. The map is wide, again, height. If we've got half tiles, we're going to ignore them. Really, if you've got half tiles, don't be silly. Don't try and cut a tile map out of something that isn't an even number of tiles. Get the tile map. So now, I want to create our tile map. And tile map, it's not argument. Get argument as string 0, and it's not width and height this time, it's map width and height. That would be a bad error. Okay, so we now create a tile map with the width and the height that we know. We won't run through all the tiles, so this is going to, we're going to run through map y is equal to 0, map y is less than y, map y, map height, and then map x, we go through all the width. So effectively now what we're doing is we're stepping tiles across our image. Each time we're going to need to create a tile. And as we know, the tile is width and height. Now, what we now need to do is read the tile image. So we're now going to step through for int tile y0. Tile y is less than the height of the tile. X is less than the width. So this is stepping through the image in map blocks, so in the tile blocks, and this is stepping through in pixels of each tile. What we need to work out is the points. Y can't change obviously during the X loop. So what we need to do, the Y is the map Y times the height of each tile plus the tile Y. So this is, because map Y is in tiles, that's in chunks of the height of the tile, and then we add our actual pixel into each tile in there. Similar in here, we can work out the X. That's going to be the map X times the width of the tile. Map X. So now we've got this, we can now pretty much copy this chunk of code, put it in here. So what it's doing is reading the pixel from our X point and Y point, it's grabbing data and it's adding it to our tile. Because when we're processing tile map, we are creating tiles all the time. What we now want to do here is tile ID, tile map, tile set. I want to add this tile to the tile set. If it's -1, we know there's a big problem, so return false. If not, we just need to set the tile in the tile map. Map X, map Y, tile ID. So we've created our tile, we've added it to a tile set. Remember, if the tile's the same as another one, this will return the previous tile ID. So that just adds to the tile map. We can get rid of that. That should be all there is to it. So just to test, what we'll do is we'll put a breakpoint in here. We'll put a breakpoint in here. Now remember what this is going to do. Our script says load the tile map, grab a tile map from these. We're actually created a blank tile and a specific tile already. Doesn't matter. It'll just add the tiles in, which can be useful because sometimes you want tiles that would always be blank. Let's say sometimes you want specific tiles to be in specific orders, so this would allow you to do that. You don't have to, you could just put the grab tile, but this is going to grab this tile map. So we'd expect certainly the first 2 rows to always have the same tile number. So set breakpoint. Let's check. So if I run this, these are quite large files, so it might take a minute. We'll go to tile and oh, stop that. As per usual, forgot to add the functions. Grab tile. What do we call it? We called it grab underscore tile map. Okay, let's try again. Just grab tiles, grab blank tiles, grab tiles, now loading our tile map. Okay, so we've got a tile. If we flick in, it's 64 by 64, and as we expect, all the tile data is the same color. Tile index is 2. That's because, remember, for the tile map main, we've actually already created a blank block and we've grabbed a specific tile. This is from tile, so we've actually, what we've done is we've grabbed this tile here as tile 1. Tile 0 is a blank tile, tile 1 is this tile. So when it's grabbing this tile, it's gone, oh, I haven't seen that tile before, which is why it's gone, this is tile 2. So that's fine. It's adding that as tile 2, the green block is tile 2. This tile, it should be the same. 64 by 64. Lots of blank data. As you can see, it's gone, oh, I found that tile, it was tile 2. Again, if we go to the next one, still tile 2, still tile 2. Hopefully, if we stick a breakpoint here, take that one out, it's going to run through and grab all the tiles. If we now look at the tile map, we can see that our first lot of data is all 2. Ooh, there's 3 on the last block. Why do we get a 3 on the last block? I wonder if my tile map's just not quite the right size. I'll have to check that. I'm not sure how to do it in this one, this editor. It's not the ideal editor to view graphics, but it seems to be grabbing data. It was grabbing quite fine, so it's more than likely an error in the image as to why it's grabbed a different tile at the end. And as you saw, it actually used the same tile. So I imagine my image is slightly off. So the last tile in each row has got a black pixel or something along the side. So that should have grabbed all our tile data. Obviously, the only thing we need to do is export the data. This is where else we'll see this is not very good as far as the reusing is concerned. What we need to do is come in here. We've got the sprite names, the palette names. So we'll duplicate more functions. We'll get tile map and tile set names. And tile map names. Now when we're outputting all data, we want to write the headers. So this is the sprites, this is the palettes. This is all the tile set information. Tile set names. Tile set names. Get the tile set. Check if it's not right. Tile sets. Things we probably want to write out for the header: tile width. So that will be tile set.get. Well, that's all tile set. Let's get rid of that. So tile set. Oh, so why isn't it finding it? Because I've spelled tile wrong. Get width. Get the height. We'll return the number of tiles as well. It's probably enough for the header and for tile maps. Again, this feels wrong, and there's a better way of doing it that I feel we can do, but when starting the tool, it seemed wrong to go overboard with weird details just for the first few, and it also shows you sort of the progression of a tool, how you can how things will change, and it's always worth going back and making these changes as things go along. I mean, I could leave it. There's no reason to change it. It's not that it's working wrong. It just feels wrong, and there's better and tidier ways of doing it, and makes it more efficient. This is a tile map. We're inviting out tile map header information, so I just realised I spelled tile wrong there as well. Let's go fix that. So the width and height of a tile map. That's probably what we need to know about a tile map. Write the data. Okay. This is where it might get more fun. So get tile set names. Tile sets. Get the tile set. Oops. Get tile set. Pass the name. Get tile set. Check is there. Now, with the tile set, we've got functions to write out binary data, but a tile set. Actually, no, we've got functions to do this. Print out all the tiles for. What we want to do is, to begin with, we want to don't have a right label. Tempted to add a right label. So a label is literally going to be write our label, and then we've got a label terminator, which is this. Okay. So now what we do is we can write a label. In this case, it's going to be tile set underscore and then the name. Now we just need to run through all tiles. So for I is less than tile set dot get num tiles. Run through every tile. So Sam tile, isn't it? Sam tile equals tile set get tile. And don't really need a name now. I can't remember. If we don't pass a name, do we actually? So our right data. Yeah, we always write the label. We could change it. We could actually make this right label now. That's true. One thing we didn't add to our right label function. Back up to our right label is we didn't make it a valid label. But And what else we could do actually, which would make sort of what we're about to do. Sorry, that's wrong function. Oops. So right label, if label dot length is greater than 0. If we pass in a 0 label, there's no point in, we don't want to write anything out. We don't want just a colon at the end. Because we've written the tiles out here, we don't really want to write a name for each tile itself. So that should be all we need for that. And the one that we'll probably have to write a new serialize function for is writing out all the tile maps. Get tile map names. Keep it consistent. Get the tile map. Get tile map. Pass in the name. Check it's not null. Write out the name of the tile map. So, the one thing we haven't got now, the last bit, is the serialize for the tile map, so we can write it out. So let's go to our tile map. Let's create a public byte. This actually is sort of Sam specific, converting a byte array. We've stored them integers. But on the SAM, we won't want integers. The chance of having more than 256 tiles on a SAM are quite slim. So doesn't matter for now because we're not worrying about the multi-platform, but we might have to come back to this for that. But for as far as Sam Coupe is concerned, or a lot of platforms really, it's enough. 256 tiles is enough. Okay, so we're going to run through all the data, and what we're going to do is I suppose we might want to end it with FF. It's almost like the C compiler doesn't know how to do it. Go through, grab all the tiles, write out the data into our array, and then return data. Okay. Hopefully, that's all there is to it. Wait for it to grab everything. Obviously, these commands we haven't written, which we can get round to. Okay, so sprites from last time palettes. Here we go. So we've got a tile set here. Our main tile set width 64. Our main tile set tile height 64. It's got 22 unique tiles, which when you think, if you were to store this tile map image as an entire image, with each of these squares 64 by 64, it's a big image. But it says, actually, I can get this down to 22 tiles. Looks about right. We've got some crossroads, which needs to store 4 corners, straights, horizontal straights. So I'm not horrified by 22 tiles. Tile map width is 64. I think it is. I think it is actually 64 tiles. I don't think that's the width of the tile. So if we go down and look at the data, There's a lot of data. It's not really SAM size when you start looking at 64 by 64, but okay, so tileset main. There's the first tile we grabbed, the set colors. Yeah, there's a lot of tile data there. And somewhere near the bottom, there we go, here's our tile map. So you can see 2, 2, 2, 2, 3, there's obviously something in that data because 3 is always down. But if we look at our tile map, you can see the first couple of rows are going to be the same, and then we start to add in a bit of a road with some tiles in. Back here, the first couple of rows are the same, then we start to add in this little road, 4, 5, 5, 5, 5, 6, 7. 4, 5, 5, 6, 7. May just have to double check. I'm just going to double check the graph tile map just to make sure that I've got the data right here. Let's run it and check. One 1024. Image height 1024. Tile 64. Tile height 64. Ah, so it says our tile map, so that's one thing that we can see is wrong, because if we go right back up to the top, it said tile map width and height were different. So we're definitely adding our tile map width and height. 16 by 16. There's less than tile map width, there's less than tile map height. Y is based on the MY. Times the width times the height, add the X, Y. So Y, go to export, output all. Certainly the header's wrong. Get tile map. That fixes that bug, so hopefully now, if we run this, take our breakpoint. Oops. One. That's better, 16 by 16. Won't count for all the data slightly wrong. I'll come back and check the image, but the actual data is right. So we can see here on this row, data block 8 for the vertical, then some more data, and then 8 for the vertical again. So it does appear to be working. I'm a little confused as well as in this. My instinct is that the image is the wrong, so I'll have to go look at the image and check. If it is, I'll post some comments in the video. It's just coming over an hour now, so we'll finish the video there. I think the tool is working correctly. I think it's just my image data that I quickly put together for it is wrong, as it's blatantly copying the data, right? So, and you can see where it's creating the tiles, and then we get some more, and again here you can see it's using 4, 5, 5. So 4, 5, then we've got the T-junction piece, then 5, 5, 5 for the horizontals. So it does appear to be grabbing the right data. It's just probably something a bit wrong with my input data. Yeah, any questions? Obviously post some comments.